In 1994, the world watched in awe as pieces of a comet, Shoemaker Levy 9, slammed into Jupiter. One after another, fireballs bigger than Earth exploded in the gas giant's atmosphere. For a week, the planet looked scarred, bruised, like it had just taken a cosmic beating. Astronomers celebrated. Why? Because it hadn't been us. That's the truth about comets. They are beautiful only when they're far away. Up close, they are executioners. They swing in from the darkness without warning, carrying more energy than all the nuclear weapons on Earth combined. One impact can erase continents, boil oceans, and reset evolution itself. It has happened before. It will happen again. But here's the riddle. How can these icy killers survive long enough to keep coming back? How does a comet spend billions of years in exile, then suddenly blaze across our skies, shedding gas and dust like it's falling apart, yet somehow not run out of fuel? Shouldn't they all be gone by now? That's the puzzle we're going to untangle, because comets aren't just frozen junk. They're survivors. They're messengers. And sometimes, they're executioners. Comets are not cosmic accidents. They are time capsules, the oldest surviving artifacts from the birth of our solar system. 4.5 billion years ago, when the sun first flared to life, space wasn't neat and orderly. It was chaos. Clouds of gas collapsed into the star. Disks of dust clumped into planets, and whatever didn't make it into a world got scattered like shrapnel across space. Those leftovers became comets. Most of them were flung outward into two vast reservoirs. The first is the Kuiper Belt, just beyond Neptune, a ring of icy debris left behind when the outer planets finished forming. The second is the Oort Cloud, a hypothetical shell of trillions of icy bodies surrounding the solar system like a bubble that stretches almost halfway to the nearest star. No one has ever seen the Oort Cloud directly, but the paths of long-period comets scream its existence. It's out there, a graveyard of frozen bullets waiting for something to kick them loose. And that something doesn't have to be dramatic. A passing star nudging the sun's gravity, the tidal tug of the Milky Way itself. Even the slow shuffle of giant planets like Jupiter can destabilize an orbit. That's all it takes to send a chunk of primordial ice tumbling inward. Once it's on that path, the clock starts ticking. The comet begins its plunge toward the sun, waking up after billions of years in the dark. Here's the unnerving truth. We usually don't know about these visitors until they're close. A comet nucleus might be 10 miles across, the size of a city, but out in deep space, it reflects almost no sunlight. To our telescopes, it's invisible. We only notice it when it gets close enough to start shedding gas and dust, building that dramatic tail. By then, the countdown has already begun. Every comet in the sky is more than a spectacle. It's a survivor of creation, a messenger from the dawn of the solar system. But it's also a reminder of how fragile our position really is. These objects were born in fire, preserved in ice, and each time one appears, it whispers the same warning. The solar system is still unfinished, and its debris can still reach us. When you see a comet streaking across the night sky, what you're actually looking at is a disguise. The bright tail, the glowing halo, none of that is the comet itself. The real comet, the part that matters, is the nucleus, a dirty, misshapen lump of ice and rock, usually no bigger than a mountain. On its own, it's invisible, as dark as charcoal, reflecting just a few % of the sunlight that hits it. If you held a chunk in your hand, you'd probably mistake it for an ordinary black rock, until it started hissing and venting like a dying engine. Inside that rock lies a frozen cocktail: water ice, carbon dioxide, carbon monoxide, methane, ammonia, and dust grains older than Earth itself. Some comets even carry organic molecules, the same raw materials life on Earth may have sprung from. NASA's Rosetta mission to Comet 67P/Churyumov-Gerasimenko confirmed it. Amino acids, sugars, even the building blocks of DNA. Comets are not just icy junk. They are chemical laboratories from the dawn of time. But the real show begins when sunlight gets involved. As a comet dives closer to the sun, its ices begin to vaporize in a process called outgassing. Jets of gas explode from its surface, dragging dust along, forming the glowing coma, the hazy atmosphere surrounding the nucleus. Solar radiation and the solar wind stretch that material into tails, one made of dust, curving gently behind, and another of ionized gas, pointing straight away from the sun like a cosmic windsock. A single comet tail can stretch for millions of miles, dwarfing any planet. Yet the solid heart that makes it all possible may be smaller than Manhattan. Here's the paradox. Comets can outgas for thousands of years, each pass stripping material from the nucleus. So why do they survive for billions? The answer is simple and unsettling. They don't. Not really. Every comet is on borrowed time. Each trip near the sun carves it down, shaves it smaller, until eventually it disintegrates into dust and rubble. The reason we still see them after all this time is that most of them don't return often. A comet from the Oort Cloud might take millions of years to complete one orbit. By the time it comes back for its second round, entire species may have risen and gone extinct on Earth. That's why every comet is both ancient and temporary. A messenger from the birth of the solar system, doomed to vanish after a handful of appearances. They are ghosts, and every time one blazes across our sky, it may well be its final scream before fading forever into the dark. Comets are wanderers, but not in the way planets are. Planets trace steady, predictable orbits like clockwork. Comets follow paths that are anything but ordinary. Stretched, twisted, sometimes so elongated they resemble straight lines more than circles. A short-period comet like Halley's, which loops back every 76 years, feels almost familiar. But the true drifters, the long-period comets, can take tens of thousands, even millions of years to complete a single orbit. For them, each visit to the sun is a once-in-a-lifetime event. Literally. Imagine this. A comet forms at the birth of the solar system, frozen in the Oort Cloud nearly 1 trillion miles from the sun. For billions of years it drifts in silence, untouched, unchanged, invisible. Then one day, a nearby star brushes past our solar system. The delicate balance is disturbed, and the comet's orbit tilts just enough to set it on a slow plunge inward. From that moment on, the countdown begins. It might take 1 million years just to reach the inner solar system, where we can finally see it. By the time it arrives, Earth's continents may look nothing like they do today, and the civilizations that witness its light will be strangers to the ones alive when it began its journey. And yet, despite those staggering timescales, comets are fragile. Outgassing eats away at them during every close encounter with the sun. The fact that we still see them means most of their lives are spent in deep freeze on those immense stretches through interstellar darkness. Each trip is like a slow inhale, followed by a single fiery exhale when they graze the warmth of our star. Here's the twist. Some comets never make it back. A close pass with Jupiter, the solar system's gravitational gatekeeper, can fling them out forever, ejected into interstellar space, never to return. Others crash spectacularly into planets or the sun itself, ending their journey in one violent instant. Every comet you see in the sky is a survivor of incredible odds, one that avoided annihilation long enough to give us a show. So when a bright comet suddenly appears in our skies, It isn't just a celestial visitor. It's the end of a story that began before humans existed. A frozen time capsule that has crossed unimaginable distances just to burn itself away in our presence. For all their beauty, comets carry a darker legacy. They are not just icy relics drifting through space. They are weapons, forged at the dawn of the solar system, waiting for the wrong orbit to unleash catastrophe. 65 million years ago, a chunk of rock and ice about 6 miles wide slammed into what is now Mexico's Yucatan Peninsula. The explosion released energy equal to billions of nuclear bombs, carving the Chicxulub crater and ending the age of the dinosaurs in a single day. Most scientists agree it was an asteroid, but some argue it might have been a fragment of a disintegrated comet, a long-period wanderer that had silently traveled for millions of years before its fiery death strike. And that's the terrifying part. Comets don't play by the same rules as asteroids. Asteroids mostly live in the belt between Mars and Jupiter, where we can track them. But comets can come screaming in from the Oort Cloud, unseen until their final approach. A long-period comet could cross hundreds of millions of miles in just months, leaving humanity almost no time to prepare. They move fast, up to 44 miles per second, far faster than most asteroids. A direct hit from one would deliver devastation beyond imagination. But comets don't need to strike Earth to cause chaos. When they shed debris, the fragments remain in orbit, creating meteor showers. Most of these are harmless, streaks of light painting the night sky. But every fragment is a reminder that larger pieces might follow. In fact, in 1994, the world watched as comet Shoemaker-Levy 9 collided with Jupiter. The impacts scarred the giant planet with dark bruises larger than Earth itself. If Jupiter hadn't intercepted it, that comet could have wandered into the inner solar system, maybe even toward us. And here's the cruel irony. The very thing that makes comets so breathtaking, their brilliant tails, is also what makes them dangerous. That glowing display means the nucleus is venting, breaking down, shedding mass. Every pass by the sun is a roll of the dice, and sometimes those dice scatter debris straight across Earth's orbit. So when we look up at a comet and marvel at its beauty, we are also looking at a reminder. These are not just celestial wonders. They are cosmic warnings. Reminders that the same icy messengers that may have delivered life to Earth can also bring death without warning. Comets are paradoxes. They can annihilate worlds, yet they may also have made life possible in the first place. For all their menace, they are also cosmic gardeners, scattering the seeds of chemistry across the solar system. Earth today is a blue planet, but in its infancy it was a scorched rock. Where did all that water come from? One leading theory points to comets. These icy travelers carry vast amounts of frozen water, locked away since the birth of the solar system. When they crashed into the young Earth billions of years ago, they may have delivered much of the water that now fills our oceans. Every wave that breaks on a shore may echo from a comet's fall. But it wasn't just water. Inside a comet's icy heart are organic molecules, the building blocks of life. In 2015, the Rosetta spacecraft and its lander Philae made history when they touched down on comet 67P/Churyumov-Gerasimenko. Instruments detected complex carbon-based compounds, including amino acids, the very molecules from which proteins form. In other words, comets don't just carry ice, they carry chemistry. The chemistry of life. Imagine the early Earth, bombarded by comets, oceans filling drop by drop, complex molecules scattering across its surface. It's a violent picture, but also a creative one. The collisions may have been brutal, but they could have laid the foundation for biology. Comets might have turned a barren rock into a living world. And this idea stretches beyond Earth. If comets can seed life here, they could do so anywhere. Across the galaxy, wherever comets fall on young planets, the same chemistry might unfold. Perhaps in some distant system, another world's first ocean was filled by the tail of a comet. Perhaps the story of life is not just Earth's story, but a universal one, written in ice, dust, and time. For most of history, comets were untouchable. They appeared suddenly in the sky, glowing with mysterious light, then vanished into the void. To ancient eyes, they were omens. To astronomers, they were riddles. And for centuries, no one dreamed of actually catching one. But in the space age, the impossible became a challenge. The first step came in 1986, when Halley's Comet made its once-in-a-lifetime return. A fleet of spacecraft from several nations was launched to intercept it. The European probe Giotto braved clouds of dust and radiation to send back the first close-up images of a comet's nucleus. For the first time, humanity saw the face of one of these icy wanderers, a dark, rugged core spewing jets of gas into space. It was not a mystical star, but a dirty snowball, alive with energy. Decades later, Europe set its sights on a far more ambitious goal. Not just to fly by a comet, but to land on one. In 2014, the Rosetta mission arrived at Comet 67P/Churyumov-Gerasimenko after a decade-long chase across billions of miles of space. Its lander, Philae, touched down on the surface, the first time in history we had set foot, however briefly, on a comet. The landing was rough, with Philae bouncing twice before coming to rest in a shaded crack. But even there, it managed to send back priceless data. Close-up images, chemical analyses, and direct confirmation of complex organic molecules. These missions revealed that comets are not just lumps of ice and dust. They are active worlds, unpredictable and dangerous. Flying through their tails is like navigating a cosmic minefield, with dust grains moving fast enough to cripple a spacecraft. Yet the rewards are enormous. Every sample, every measurement, is a clue to the birth of the solar system. And there is another reason to chase comets: the future. Comets are rich in water ice, carbon, and even potential fuel. Some scientists believe that one day, explorers could harvest comets as way stations, refueling posts on the road to the outer planets or even interstellar space. The very things that make comets dangerous also make them valuable. Humanity's pursuit of comets is far from over. Each mission pushes the limits of engineering and imagination. Each encounter brings us closer to understanding not just how comets work, but how they shaped our past, and how they might shape our future. Comets don't care about us. They don't care about our cities, our telescopes, our fragile blue planet. They were here before us, and they'll be here long after we're gone. That's what makes them so unsettling, and so fascinating. Some carry the building blocks of life, fragments of chemistry older than Earth itself. Others are potential harbingers of destruction, cosmic bullets that remind us just how thin our margin for survival really is. And yet, maybe that's the real point. Comets are reminders that the universe is not tame, not safe, not polite. It's raw, violent, and breathtakingly beautiful. A comet doesn't glide across the heavens to put on a show for us. It's simply passing through, following an orbit carved billions of years ago. We're the ones who give it meaning. That's why we chase them, why we land on them, why we risk billion-dollar missions for just a few minutes of data. Because every comet is a messenger from eternity, a frozen postcard from the dawn of the solar system, carrying secrets that no other source can provide. Someday, we might mine them for water, or use them as stepping stones into deep space. Someday, one might have our name on it, barreling straight toward Earth with no escape plan. Either way, they force us to look up, to think bigger than ourselves, to remember that we're passengers in a universe far larger and wilder than we usually admit. So next time you see a comet streak across the sky, don't think of it as a pretty light. Think of it as a messenger, older than mountains, colder than ice, and carrying the universe's blunt reminder: nothing lasts forever. And if this cosmic journey gave you chills, sparked your curiosity, or made you see the night sky a little differently, hit that subscribe button and give this video a thumbs up. Every comet, every star, every whisper from the void deserves an audience, and you could be part of it. Keep watching the sky with us. The universe isn't waiting, and neither should you.